Hello YouTube, I am Orange Peter. Welcome to day 5 of my Minecraft calculator project. So, day 4, I did a bunch of kind of boring stuff. One thing I made this thing. Was a little bit lazy with the design, however. I kind of just made it partially. So I did that, and I also basically did this whole section right here, all these 3 components. I redid that for the other segment of my display. So this is for the first input set of digits, and the other one is for the second set of input digits. Here you can see the 3 components I've made. Again, I kind of cheated on this one because I know that only 1 zeros can be fed in. Decoder, it's all exactly the same, or at least the functionality is exactly the same. I made the decoder slightly different. Like, this section on the left I made a little differently. I don't remember exactly why. I think I had some space issues, but it's not really important enough to mention. It just made some minor tweaks to make it a little bit easier a little bit cleaner to implement, is really all I did. Yeah, next is to actually build physical 7-segment displays. So I'll just wire up my what I have now, circuits, to the individual segments of the display, and it should all go fairly smoothly. Alright, here is my 7-segment display. I think it looks pretty good. You can see there's the 8 right there. Seems to be working okay. It was a little harder to input than I expected. You can see that the circuits are into a little mess of spaghetti behind here. It's all wiring quickly, and I did make some mistakes. For one, I actually looked at it the wrong way. I looked at it as if the left side was the less significant digit. Sorry, so it's if it was 14 and 1, and then 4. You can see how I'm saying that. However, in reality, it's the other way around. So when I was working with it, I was working with like a mirrored version, looking at it from the wrong side. So in order to fix this, for number 1, I had to flip the digits, which is why I have these chords crossing here. I had to go back and do that after I basically finished everything. And another thing that I had to do, what ended up happening was the numbers were also mirrored as a result of me thinking about it in a weird way. But I didn't want to redo the whole spaghetti mess, so I just kind of rewired my circuits in the decimal to 7-segment converter thing, which, as I mentioned in the previous video, is not very hard to do. So that's how I fixed that. It ended up being kind of more messy than expected, but now I guess we're gonna do a demo. Alright, so this is to show you that it actually works. I actually had some trouble thinking about the aesthetics when I was making this. You can see I made the left side, I made the blocks distinct, while on the right side I made them kind of blend in. I like the idea of them blending in, because you can't, when they're not, when they're all pulled in, you can't tell there's a screen there. But at the same time, when they're blended in, you can't see them as well, and I was disappointed to see that you really can't see them as well. So that's why I made the blocks more distinct on the left side. I plan on, I might even convert it over to a redstone lamps as I've been doing, but I think that'll be a little bit of a shame. I guess we'll see. But yeah, so I just went from 8 to 9 to 10, and you can see that it looks pretty good. The transition, it's slow, but you know, people don't make stuff in Minecraft to make fast applications. Oh well. Next I'm going to work on the second part of the display, and we'll see how that goes, I guess. Alright, so I've completed the input for the second digit. You can see that over here, and I have also, I don't know, I made the wall for where the eventual output would be wired, but I don't actually have that wired up. So you can see that it works, and it will obviously take a little while, but it does work. Actually, no, it does work. Okay, yeah, so it works. I expected not to have as many issues this time, and I did remember to, you know, mirror things. When I was working on it, I thought about it in the correct way this time. I went ahead and switched the wires and mirrored the circuits in my decimal to 7-segment converter, but there were some other issues. The thing is, for each of these to have 7 chords, it's about 14 blocks wide, and each number isn't actually 14 blocks wide, so there's some space issues. On the first one, I could kind of expand to the right and left a little bit, but this one over here is kind of cramped. So you can see this one is actually expanding way over here, completely getting in the way of this digit and of one of the output digits. And I've kind of tried to worked through that, because if I made this one go further to the right, it would completely cut off this digit right here. So I had to kind of have it snake its way through the mess of that digit over here to stick out this way, and it's been quite a mess getting that to work, and this looks like quite a mess. Probably is an actual valid good way to do this, but I haven't done so. But yeah, it works, and it's quite a magical feeling seeing these numbers. And it's just wiring the circuits to the individual segments, but it's kind of really neat seeing numbers work. Still feeling motivated, so I think I'm going to go ahead and add the actual logic of the calculator. Wish me luck. Alright, I'm pretty excited right now. We have a working calculator. The core, or the purpose of this project has been completed. We have a calculator, which will take in 2 4-bit numbers and add up a 5-bit number. So let me run through the process real quick. So I have these two numbers, 0 1 0 1 and 0 0 0 1, and we're going to add them together. So if I were to work this out on paper, it looks something like this. Basically the same as if you're adding decimal numbers. You just start with the smallest digit, add them together. If they're more than 2 digits, the second digit goes over and the first digit stays. Make sense? Alright, so we'll go through this. So 1 plus 1 is 1 0 in binary. So the singles digit is 0, which is why that's there. And the carry, or the, I guess, 2's digit gets carried over. It's an overflow, basically. And then in this one, it's 1 plus 0 plus 0, 1, and yeah, it's a pretty similar idea. But let's talk about in specific this area. So we have 2 inputs and 2 outputs. How do we figure out what those inputs and outputs are? Well, the circuit for this is actually called a half adder. And I have an image right here of a half adder. So we have our 2 inputs, A and B. And to get our singles digit, or the sum, we actually use this thing called an XOR gate. An XOR gate is only true if one and only one of the 2 inputs are true. So if they're both true, it's false, and if they're both false, it's also false. So if you think about this, if they're both 1, then it's going to overflow, so this should be false. And if they're both 0, then 0 plus 0 is 0, so therefore the sum should also be false. So XOR makes sense. And let's see, and then here, to determine whether it overflows, we have an AND. An AND is only true when they're both true. And if you think about it, we will only get an overflow if they're both true. So this AND also makes sense. So we have the XOR for the first digit, and we have this AND for the second digit. Okay, now for this next section is a little bit more tricky. It's we have to work with 3 inputs rather than 2. And the circuit for this is called a full adder. So I'm going to Google that. Or I'm going to run a search on full adder, because Google doesn't like people. I don't know if you guys know this, but Google doesn't like it when people say Google it, because if you use Google as a verb, it runs the risk of being adopted into the English language. And if it's adopted to the English language, copyright laws don't work. So to make Google happy, you should say I run a search on this, as opposed to Googling it. That's a fun fact. Okay. Anyway, so this is a full adder, and as you might expect, a full adder has split in 2 halves, which is 2 half adders. So we have the A and B, which run into an XOR and an AND again. But then you take the output of the XOR, and as well as our carry from the previous number, and we run that into an XOR and an AND again. So let's look at the XORs and talk about how that gives us a sum. So if you think about having these 2 XORs together, combining to take into account all 3 of these variables, this final value is only true if there are an odd number of ones. So we can kind of look through that. This XOR will be true if only one of them is true, so if it's odd. And then this one will be true if this one is true. This will be true if the other input is false. So if this is odd, and this is false, then it'll still be odd. Alright? Whereas if this one gives a true, and this one's a true, that means that this is a 1, and a 1 plus some odd combination is a even. So that would be false in that case. And you can kind of go through all the possibilities and find that the sum will always be 1 whenever adding up is odd. And if you think about it, there will only be a single digit when it's odd, because if it's even, that means it all goes into 2's digit, or it'll all go into this carry out. Okay. Now let's think about this these ands. So this and will be true if A and B are true. So that means that this and will be true if 2 of them are true. This and will be true if both of these are true. So both of these will be true when this guy is true and at least one of these is true. So these will both be true if 2 or more are true, is actually how that works out. And if 2 or more are true, then we want to send out a carry, because that means that we've overflown our single digit. So we take into account both these cases with this or, and if either work out, then we send out a carry. Let me think for a second what will happen if we have them all true. Yeah, so if they're all true, then these two will automatically enable this one, and that will work. Okay, but if one of these is false, then this would have to be true, and that would enable that one. That would work. All right, that's the full adder. Let's look at my circuit, and we'll see how this works in Minecraft world, not IRL, Minecraft world. Okay, so this is the beautiful circuit. It's nice, and you can see kind of symmetric patterns, and it's quite a pretty thing. But let's look over here. So I have all my inputs, and I gather up both the 0 digits, or the 1's digits, over here. You can see there's my 2 1 digits. Let's break into here, and we'll take a better look. Didn't make the ceiling very high. Oh well. Alright, so right here, I have this 5 block thing, which is my XOR, and I have this, which is my AND gate. So right now they're both true, so they get fed into the XOR, and they end up being false, because if they're both true, then we send a carry over, but the single digit is false because it's 1 0 would be the sum of 2 binary digits. So since they're both true, this and should not be true, and we send a carry over. Alright, now the next part. So this is our half adder, just this and this XOR. And then for our full adder, we have another half adder right here, and a half adder right here. So I have 2 half adders. I take the result from this XOR, feed it into this other XOR over here, with also being fed to this XOR is the carry from the previous one. See that? And then the carry from this previous one is fed into an AND with that same XOR. And then I have this AND, which turned out to be an OR, this circuit right here, because it connects to this AND over here, and this AND is done with the XOR from the second digit as well as the AND right here. So it's a little bit confusing to explain. I tried a lot harder to explain it last time, and I feel like I kind of made it more confusing, but really, if you might want to pause the video, look at those diagrams I showed you earlier, and just think through it, and it'll make sense. And then it's really just that same process repeated over and over and over again. And we end up with our output heading out over here, and we have 5-digit output. It's quite a nice thing. So we've accomplished what we set out for. We have 2 numbers that are added, except now we have it in the format of 5-bit binary number, but we want to convert over to a decimal for our display. And that's something I'll be doing next time. I think the hardest part is still ahead of me, actually, because let's see, to do this, it won't be. I should say the most tedious part is ahead of us. It won't be necessarily hard to figure out, but I basically make another one of these decoder along with some binary to 7-segment converters. And the thing about the binary 7-segment will be exactly the same, but this will be a little bit different because our new one will take in 5 digits instead of 4. And as you expect, to be a little bit bigger, but the thing is, it's not just a linear scaling. 25% more digits does not mean 25% bigger decoder. It's actually, for every extra bit we have, for every extra digit we have, this decoder is twice as big. And let me remind you that this decoder is already the biggest component I have. So I need to make another one, and that's going to be twice as big. So it's going to be very tedious to throw that together. But then after that, setting up these two converters right here, as well as wiring my my display over here, that shouldn't be too hard. So I look forward to finishing it next time for day 5. 5 is my favorite number.